Here we have a beautiful reddish solid. This is a fluorescein sodium salt. It looks like an ordinary powder, but it has a special property. It glows in bright color under light. And this is the structure of the molecule. What happens if I add water? And then I will shine my light. So as you see, if I shine light, it becomes green. If I don't shine, it seems red. So this is, I think, very interesting. What happens is that solution suddenly shines bright green. This is a photoluminescence process, and the process where a material absorbs light and energy. So light is an energy, and it re-emits as a different color. So therefore this is a very interesting phenomena. Photoluminescence is the process where a material absorbs photons and then re-emits them as a light of a different energy. There are two types of photoluminescence. One of them is fluorescence and the other is phosphorescence. Fluorescence is very fast emission, occurs almost immediately after excitation. Phosphorescence is slower emission than fluorescence, and it happens when excited electrons get trapped in triplet states and electrons return from triplet state to singlet states and emit light. Phosphorescence can last for microseconds to minutes. We can use a diagram to explain the event. Firstly, we have a singlet state and vibrational states. So this is S1 and these are the vibrational states. We have S1, again we have vibrational states, and we have S2, and we have also its vibrational states. So firstly, an absorption occurs when we shine light on the sample. For instance, light excites the electron to the S2 state. And internal conversion can occur. For instance, this can go to the S1 state. It's a fast process, by the way. And electron can move to S1 to S0 state. And this process is called as fluorescence. In phosphorescence, what can happen is that the electrons can go from S1 state to triplet states. However, this is not allowed, and it is called as forbidden state for our electrons. But it can happen, and this takes time, and electrons, after going to the triplet state, they can go to the S0 state, and this is called as phosphorescence. And these triplet states are shown by T1. But what is the singlet and triplet states? Electrons have spin plus 1 over 2 or minus 1 over 2. And electrons are fermions and they are affected by magnetism. In a given orbital, two electrons can occupy the same orbital if they have opposite spins, which is called as Pauli exclusion principle. If two electrons have opposite spins, total magnetic moment becomes zero. And we can show the electrons on an orbital. For instance, this is an orbital, and I want to show the plus 1 over spin like this and minus 1 over spin like this. So we are using the arrows. S is equal to plus 1 over 2 minus 1 over 2, and it is equal to 0. If two electrons have the same spin, the magnetic effects adds up. And the spin multiplicity is given by 2s plus 1. If two electrons have the same spin, for instance, it is 1 over 2 and 1 over 2, then s becomes 1. And spin multiplicity becomes 2s plus 1, which means that it is 3. And this is simply a triplet state. But if the electrons have the opposite spins, then s becomes 0 and 2s plus 1 becomes 1. And this is called as the singlet state. And basically, a triplet state occurs when two electrons are unpaired with the parallel spins. Why triplet states are important? In photoluminescence, intersystem crossing is observed for phosphorescence. An electron can flip its spin and land it a triplet state. Returning from T1 to S0 requires a spin flip, which is forbidden by quantum rules. Therefore, the process is slow and it causes phosphorescence. Triplet states is usually lower in energy than the excited singlet because electrons with parallel spins avoid each other more. Less overlap causes weaker electron-electron repulsion. Photoluminescence is a useful technique for the study and characterization of materials and dynamical processes occurring in materials. Photoluminescence is useful in qualifying optical emission efficiencies, composition of the material, impurity content, and layer thickness. To make the photoluminescence spectroscopy, we need a spectrometer, and it is a complicated system. First, we generally use a UV source. So we have a UV light source, and this source is actually pretty strong. We may need to cool it. So there is a airflow, and this airflow cools the lamp. We have an excitation monochromator, and light passes from the monochromator. We may use a filter. After the filter sample interacts with the light, and we can use another filter. Since observing photoluminescence is not easy for many samples and we may need so many filters to get rid of unwanted light, and we have a emission monochromator. So this is the emission monochromator and a PMT detector. So this is excitation monochromator and this is the emission monochromator. And filters are important. Since excitation light is much stronger than photoluminescence emission, if you don't block the excitation, the detector will be blinded and you can't see the photoluminescence spectrum.